Jai Hind everyone. I am Dr. Sneha Mishra, Assistant Professor, Department of Computer Science and Engineering, AKGEC Ghaziabad. So we will be delivering the content on compiler design. This is the course included in BTech and as well as MTech also. So the topic which we will be covering today will be about the language processors. So basically, what are the language processors? So language processors, these are the program that accepts source language as the input and translates it into the another language that we can also call as the target language. You must be aware of that we have some programming languages like C, C++, Java. So each and every language, each and every program which we write in our compiler, that is the source program. So the language processor work is to accept that source language as an input and translate it into the target language. And what is that target language? So that target language is which is understandable to the machine. So the language processors are used for software development without worrying much about the architecture of the machine, right? So that is the programmers can ignore the machine independent details during the software development. So it performs translating and interpreting a specified programming language, right? So this is language processor. So just you have to remember is that a language processor is a program that accepts the source language as an input and translates into the target language as an output. So language processors are for software development without taking care of the architecture involved, right? So what are the types of language processors? So if we talk about, we have preprocessors, we have compiler, we have interpreter, we have assembler, we have hybrid compiler. So one by one we will get through all these, and this will be the content which will be covered in today's lecture. So what is preprocessor? The preprocessor again is a program that accepts the source program as an input and prepares the input program for compilation. I'll show you the diagram also how this works. So the source program is divided into see what is it that the preprocessor is a program. Again, it is a program. Which type of program? That accepts the source program as an input and prepares the input program for the compilation. So before going for the compilation, the process of converting that source program for the input of compiler, that is known as preprocessor. A source program is normally divided into modules and will be stored in separate files. So all these files are collected by the preprocessor with the help of hash include directive. This you must be aware of, that all these files are collected by the preprocessor, and this is denoted by hash include directive. So preprocessor may also be explained in shorthands which are called as macros into the source language statement with the help of define directive. So include and define. These are how we define the preprocessors, or we explain the preprocessors, right? So now let's take the source program. Okay, this is the source program, right? Now how will we identify that this is a preprocessor? I have already told you that hash include and hash define, these are the preprocessors, right? So if in a source program we are saying stereo.h, or we are saying define max is equals to 5, and so this is the source program actually. right? So this is the source program. Now, this source program, what will the preprocessor do? This preprocessor will program it for the compilation. It will provide this, the expanded form, the contents of file stdio.h are included, right? The content of the file stdio.h are included here. Rest the program is written like max you have given 5 na. Here you have defined max is equals to 5, so max is equals to 5. So this the preprocessor is giving input of this program to the compiler for compilation, right? So what happened? We have given a source program. What does the preprocessor has done? Preprocessor has programmed it into such an input so that it can be given to the compiler and for compilation, and the compilation will be in the form of object program, or you may say binary form. So such is how our preprocessor works, right? So this is preprocessor. Now it is the job of compiler. What does the compiler do now? So the compiler is basically a translator. You have seen in the previous slide that what the compiler is doing. It is converting it to an object program. So compiler is a translator that accepts the source program written in high level language by us in C, C++ or anything, and converts it into the object program and the low level language such as assembly language, right? So what does the compiler do? It translates our source program which is written in high level language and converts that into the object program or low level language which is understandable by the machine. So here is what are the contents it is covering. So the syntax error are identified. First of all, syntax errors in compilation, right? So in compilation, syntax errors are identified and appropriate error message are displayed along with the line number. You have seen whenever you are doing a C program, you have and you are doing compilation, at that time you get errors. And what are those errors? Those errors are your syntax errors. The error message is generated by the compiler and with the line number also, right? So in further you will be studying symbol table and error handler. You will learn how this error message and line numbers are being generated. So the compilation is an optional list file can be generated by the compiler. The optional list file also can be generated by the compiler. The compiler replaces each executable statement. See, it replaces each executable statement in high level language into one or more machine level languages instructions. So what is the compiler doing? It is replacing the executable statements. It is replacing the executable lines of codes which are in high level language, which are written in high level language, into the machine level instruction or machine language instruction, right? So it is converting high level into assembly language or object program if the program is syntactically correct. So first of all, it is checking the syntax errors. If this step is fulfilled completely, then it is converting this high level language to the assembly language if it is syntactically correct. So don't worry about this, syntactically correct or not. This will also be studied in future lectures. So, so you can understand the gist of the compiler. The gist is that it is accepting the source program which is written in high level language, and it is converting that source program into the low level language which is such as assembly language, right? So first step is to identify the syntax errors. Then those the error messages are displayed. If the program is syntactically correct, then the high level language is converted to the assembly language So this is the work of your compiler. You can understand with this short block diagram also. It can be pictorially represented like you have given the source program here, and this is the target code, and this is the target object. So this is the source program. After compiling, it is giving the target program, and if there is an error message, there this is giving the error messages. So if the target program is executable machine code, it can be called by the user to process the inputs and produce output. So user inputs and outputs. So the target program is giving the outputs. So this is how we represent that how these compiler is working. If the source program is syntactically correct, then straightforwardly it will generate the target program, but if it is not correct, then error message will be generated. If the target program is an executable machine code, it can be called by the user to process the inputs to produce the output, right? So user input is given here in the to the target program, and after getting the user input, it is producing the output. So this is how this compiler is working. Now there are two things. Many students get confused between what is the difference between a compiler and an interpreter. We will in this lecture only, we will discuss about this, how the compiler and the interpreter is different from each other. But let's first study what is interpreter. So how the interpreter is working? Interpreter is a translator. It is a translator. What was compiler? Compiler was also the translator, but the working of both are little bit different. That accepts the source program, compiler also accepts the source program written in high level language. There also it was written in high level language, and converts it into the machine code and executes, right? So same thing is here also happening, right? The interpreter converts one high level language statement. Now the twist comes. The interpreter converts one high level language statement into the machine code and executes immediately. There, if the whole program was syntactically correct, it was syntactically error free, then only the program was getting executed to the object program or the assembly language. But here in an interpreter, it is checking the high level language statement and converting it into the machine code then and there immediately, but that particular statement only, right? So the statements within the loop are translated into the machine code each time. So if there is loop, then the statement within that loop is translated every time. So the control enters into the loop, right? The control enters into the loop. Whenever an error is encountered, now see, now comes the error part, right? So whenever an error is encountered, the execution of the program is halted and an error message is displayed. What was there? Whole program, in compiler, whole source program was being checked whether it is syntactically correct or not. If it is syntactically correct, then it will convert it into the object program or assembly language. But here in an interpreter, it will check if the control is on one loop. So that loop will be checked. If there is an error, program will be halted and error message will be displayed. And until and unless that error has been removed, it will not go further. So interpreter is checking line by line, we can say, right? So this is how the interpreter is working. Now, yes, I told you that we will discuss about the difference between interpreter and compiler. So the first difference is that it converts the entire source into machine code. What? Compiler converts the entire source program into the machine code. The linker uses the machine code and creates an first of all, I'll skip this slide, and first of all I'll tell you what is assembler, linker and loader, then I'll come back to this slide. So what is assembler? An assembler is also a translator, but it converts assembly language program into the equivalent machine code, and there it was the target program, but here it is the assembly language program. It is converted in the machine code. The machine code thus produces written into the file called object program. So here you can see in the block diagram, this assembly language by the assembler is converted to the object program, right? If there is an error, the error message is being generated. So this is the assembler. And what is linker and loader? Let me tell you. Linker is large program are often compiled in pieces and generate object programs and stored in the files. What does then linker do? Linker or linkage editor, you can also say linker as linkage editor. It accepts one or more object programs generated by the compiler and links the library files and creates an executable file. Right? So the linker resolves the external reference symbols where code in one file may refer to the location of another file. Right? So simply you have to remember this, that linker resolves the external reference symbols. So you can refer the location of another file in this file. So that is the linker. And what is loader? So loader is a part of an operating system that is responsible for the loading programs in the main memory for execution. So this is one of the important stages in the process of executing a program, because loading a program involves reading the contents of executable file. So the loading of file containing the program text into memory and then carrying out other tasks to prepare the executable file for running. Once the loading is complete, the operating system starts the program by passing control to the loaded program code and the execution begins. I have told you linker and loader in between because for in the difference I can find there is the term used linker, right? So let's come back to the difference of interpreter and compiler. So what does the compiler do? Compiler converts the entire source program into the machine code. The linker uses the machine code and creates an executable file, right? And the interpreter takes the statement at a time. I have told you that it takes one statement at a time. Remember this is the major difference between interpreter and compiler. It takes the entire source program, but it takes the one statement at a time and translate into the machine code and execute that instruction. Next is the compiler will not execute the machine code. The interpreter executes the machine code generated, right? Then here the compiler requires more memory while translating. Why it requires more memory while translating? Because you have seen that it converts the entire source program. It converts the interpreter require less memory because it requires only one statement at a time, but it requires the memory for complete source program, right? So compiler is not required to execute the executable code, but interpreter is required whenever the program has to be executed. Object program is created only when there is no syntax or semantic error in the program, but it can be at the very statement we receive the error, the program will get halted, but till that time it will execute completely. So compiler program run faster, but interpreted code runs slower. So this was the today's content. We have covered this. Thank you.